Hello everyone, and welcome to our math tutorial. Today, we're going to talk about one of the most fundamental, simple, and yet most powerful ideas in all of mathematics. It's an idea so simple that a child can draw it, but so important that it built the foundation for everything from architecture to space travel. Look around you. Can you see anything perfectly straight? Maybe the edge of your desk, the top of this whiteboard. Today, we're going to become explorers. We're going to discover the true, pure mathematical idea of a line. Let's begin our journey. Before we open a textbook, I want you to think with me. I have a piece of string here. Is this a line?
No.
Now, is this a line?
Yes and no.
It's close. It's a great model. But let me ask you two questions. First, does this string have a beginning and an end?
Yes.
Exactly. It ends right here at my fingers. Second, if I zoomed in with a super powerful microscope, would this string have a thickness, a width?
Yes.
Perfect. So our physical world gives us good models, but the mathematical idea is even more pure, more perfect. In math, a true line has no ends and no thickness. It's an idea of a perfect, straight path that goes on forever. We use things like this string or this ruler to help us imagine it, but our minds have to take it to the next level. Our story now takes us back in time, over 2,300 years ago to ancient Greece. A mathematician named Euclid was about to change the world. Euclid was like the ultimate rule maker for the game of geometry. He decided to start from scratch. He began with three simple ideas that no one could argue with. First, he said, imagine a point. He defined it as that which has no part. It's just a location. We can draw a dot to represent it, but the true idea has no size. We label it with a letter, like point A. Next, he imagined a line. He called it a breadthless length. It has infinite length, but zero width. We draw it with arrows on both ends to show it goes on forever. But his most important rule for us today was his first postulate. He said, you can draw a straight line from any point to any other point. Think about that. If I give you any 2 points in the universe, there is one and only one straight line that can connect them. Those 2 points define the line. They lock it into place. This was a revolutionary way of thinking, building an entire logical system from just a few simple rules. First, the line segment. This is the friendly, familiar one. It's a part of a line with 2 endpoints. Think of a pencil, a straw, or the edge of a book. We name it by its endpoints, like segment AB. Next, the ray. A ray is like a line that got a starting point and then decided to go on forever in just one direction. Think of a sunbeam. It starts at the sun and goes out into space infinitely. We name it starting with its endpoint, like ray AB. And finally, the superstar we've been talking about, the line itself. No endpoints, infinite in both directions, named by any 2 points on it, like line AB. Knowing the difference between these three is key to speaking the language of geometry correctly. For 2,000 years, people thought about lines and shapes just like Euclid did. Then, in the 1600s, a Frenchman named René Descartes had a brilliant idea while, legend has it, lying in bed and watching a fly on his ceiling. He thought, what if every point on this plane could be described by an address, a pair of numbers? This became the coordinate plane. The horizontal line is the x-axis, the vertical line is the y-axis. Where they meet is the origin, 0, 0. Now watch this magic. What if I want to describe a line with numbers? This, my friends, is an equation for a line. It looks like algebra, but it's secretly a map of a geometric shape. Let's see how it works. It says for any point xy on this line, the y-coordinate is always equal to 2 times the x-coordinate plus 1. Let's prove it. If x is 0, what is y?
1.
Right. Y equals 2 times 0 plus 1 equals 1. So we have a point at 0, 1. Let's plot it. If x is 1, what is y?
3.
Yes. Y equals 2 times 1 plus 1 equals 3. 0.13. Let's plot it. If x is 2,
5.
0.25. Let's plot it. Look at that. All the points that obey the rule y equals 2x plus 1 form a perfect straight line. This was a revolution. It connected the world of shapes, geometry, with the world of numbers and equations, algebra. Now we could calculate with lines, find where they cross, and use them to model the real world. If you have any questions, drop them in the comments below. Thanks for watching. See you in the next class.